Hello students, today I am going to teach you 10th maths and my name is Ashok Rajput. Today I will explain polynomials. In polynomials, first we explain the applications, then theory. Okay, so you will be very careful because it is very important time. So I am going to tell you polynomials in real life. When we understood anything, it is useful for me, how we use this one, then we will careful. So see these uses in our real life. To find the path of throwing ball, the path of the throwing ball is parabolic. As you are seeing in the figure, it is the shape of like parabola. When we draw the graph of quadratic polynomial, the graph is parabolic. As quadratic equation we have to be easy for you. Ax square plus bx plus c equal to 0 is quadratic polynomial. To find the distance and the speed after some time of moving by car, bus and train or another vehicle, and with the help of polynomial we can find the speed. So to find the acceleration when we applied force on the body, as we have used in physics, are if F equal to ma. Here F is force, m is mass of the body, and a is acceleration. When we applied force on any body, uh, then we can find the acceleration of the body. And calculating the speed and height of freely falling body under gravity, we want to find the speed after at some height and want to height at after some time. So we can use these polynomials. V square equal to u square plus 2gh and h equal to ut plus half gt square. So these are uses of polynomials in our daily life because we applied force also, sometimes we throw balls also and other metals also, or sometimes we throw the many things and we are watching its path is parabolic as you are seeing in the figure. So it is very useful in our real life. We can now we will explain the next. It is theory. Theory is important to start any subject. First, we want to know what is this chapter, what are these things. So, first, we clear these things in theory and define some also. Now, as polynomial, first we define what is the polynomial. A polynomial is x in algebraic expression containing only non-negative integral powers. It is very important. Non-negative integral powers of x when arranged in ascending or descending order. It is also compulsory. It should be arranged in ascending or descending order, but mostly be used to descending order to arrange this one. But we have written here the first example in ascending order: a naught, a1 x, a2 x square, a3 x cube plus then plus an x raised to the power n, where x is a variable. Now we the classify the polynomials. First we classify the polynomial based on terms and after that the based on degree. First we classify these one which are based on terms. There are five types of polynomials: monomial, binomial, trinomial, zero and constant. Then here are five types of polynomials. After that, we will define in the next the degree based classification of polynomials. There are four types of polynomial: linear polynomial, if its degree is 1, quadratic polynomial if its degree is 2, cubic polynomial if its degree is 3, biquadratic polynomial if its degree is 4. Now we are going to the next and explain and define the terms-based polynomials. First we define the monomial. A polynomial having only one term is called monomial. As we are seeing here, 3x raised to the power 4x cube 4x at extra. Such way we can write many examples. We have written here 3. Here we are seeing term is only 1. Here. And binomial. A polynomial having two terms is called binomial. As examples, we are seeing x square minus 7, 5x square plus x square plus 7, add extra. Here we are seeing everywhere two terms. Here also, here. So it is binomial. Trinomial, a polynomial having three terms is called a trinomial. Here terms should be three. We are seeing in the examples x square plus 2x plus 5, x cube plus x plus 7, x cube plus 3x square plus 5 at extra. Now we are going to define the zero polynomial. A zero polynomial has no degree. A zero polynomial has no degree or coefficient of each term is 0. As 0x raised to the power 4, 0x square, 0x. If we multiply these terms by 0, we will get the 0. So these are zero polynomials. Constant polynomials. A polynomial having only one term equal to real number is called a constant polynomial. Constant polynomial if its value is a real number and term is only one. It, so it is a constant polynomial. It means unchanged value. If term has the value unchanged, so it is a constant polynomial. Now we are going to define the next as geometrical meaning of zeros of polynomial. The graph of linear polynomial will be a straight line and coordinate of the point where graph cuts the x-axis is 0 of the polynomial, or the value of x at which the value of y is 0. It is very simple. The value of x at which the value of y is 0 of the polynomial is called 0 of the polynomial. It is simple for understanding. Now we have fx equal to 2x minus 4, 2x minus 4 equal to 0, or we transpose the 4, here it is negative, so it will be positive, 2x equal to 4. Now we have divided it by 2, so x will be 4 by 2, 2 to the 4, the value of x is 2. Now we will mark on the number line, it is in origin point, so its points are 0 0. Here we are saying it is marked 1, it is 2, because here value of x is 2 and y is 0, so it is a 1 0 of the polynomial. So if we are going to find the 0 of the polynomial, so it has only 1 because its degree is 1 also, and why it is 0 because here we are seeing the value of y is 0. So it is 1 0. Now we are going to the next. A relation between the zeros and the coefficients. Yeah. If alpha, beta are the zeros of quadratic polynomial, as we have written here, ax square plus bx plus c equal to 0. Therefore, x alpha plus beta equal to minus b upon a, as we are seeing, and see here alpha plus beta equal to minus coefficient of x upon coefficient of x square, and alpha into beta c upon a. Then we can write it alpha into beta equal to constant term, here constant term is c, and coefficient of x square is a. So we have written here also. Now, if here we have written alpha plus beta and alpha into beta. If alpha and beta are the zeros of the given polynomial and we want to find the we want to find the quadratic equation, because here the zeros are 2, so it is quadratic x square minus alpha plus beta in the bracket. First we add it into x plus alpha into beta. Such way we can find the equation also, if zeros are given. Here if quadratic equation is given, so we can find the sum of zeros and multiplication of zeros. If zeros are given, so we can find the quadratic equation using this formula or this method. Now, relationship between the zeros and coefficients next. In the first there are two zeros, here are three zeros. If alpha and beta and gamma are zeros of cubic polynomial, as cubic polynomial is given here, ax cube plus bx square plus cx plus d, then we can find sum of roots alpha plus beta plus gamma equal to minus b upon a, alpha into beta plus beta into gamma plus gamma into alpha equal to c upon a, or alpha into beta into gamma equal to minus d upon a. If zeros are alpha, beta, gamma are given, then we can find the cubic polynomial as x cube minus x square, the sum of zeros here, plus x into alpha into beta plus beta into alpha plus gamma into alpha minus in the bracket the product of all zeros, or we can write it alpha into beta into gamma equal to 0. This way we can find the cubic polynomial also if zeros are given. Why it is cubic polynomial? Because its degree is 3 and zeros are 3. Let alpha and beta are zeros of polynomial ax square plus bx plus c. See, as we have written here again, let ax square plus bx plus c equal to 0, then dividing by a both sides, then we get here a by a is cancelled, here b by a, here plus c by a. Now we will complete this square and transpose this c upon a to the right side, because here it is positive, so here it is negative minus c upon a. After that we are seeing here, see here it is x square, and so here will be in the identity 2 and value of a. A is x, and we want to solve this problem, but value should be same. Then we have here already it is written b by a, so we have written b by 2a. Why we have written b by 2a? If we cancel it 2 2 1 ja 2, then it will be b by a, as it is written here b by a. Now it is 2ab form, so value of a is x and value of b is b by 2a. So we will write here square a square plus 2ab plus b square. Now we are saying value of b is b by 2a, so we have written here b by 2a and the square of this one, because it is not mentioned So it is extra value. If it is extra to the left side, then we will add this one to the left side also. So we have added here by to a whole square, and now we are saying it is a, it is 2, it is ab, it is b. So it is in the form of a plus b whole square. So we have written here x plus by 2a whole square. Here we have break the bracket, it is b square. Now square of 2 is 4, so it is 4 square. Now we will take the LCM. LCM will be 4 square. If we divide it by a, then it will be 4a. Now multiply minus c to the 4a, it will be minus 4ac plus b square. Now because here it is whole square, but we want to find the value of x only, how many roots are there. So we will find the square root of the left side, and taking square root both sides we can say also x plus b by 2a equal to plus minus under root b square minus 4ac upon 4 square. Why we have taken here plus and minus? Why we have taken? Because if we going to square of positive value, it will be also positive. Same thing, if we going to square of negative value, it is also will be same thing. So we can take here two sign plus and minus. So after that we will, because it is continue, it is not completing here. So we will tell you the next. Now x plus b by 2a equal to plus minus under root b square minus 4ac upon 2a, or x equal to minus b, because we have transposed this one to the right side, so we have changed the sign also. Minus b upon 2a plus minus under root b square minus 4ac upon 2a. Not after that we will take the LCM, it will be 2a. Here will be minus b plus minus under root b square minus 4ac. Here we are saying the value of x are with the sign of plus and minus. It means they are 2. So we will write these separately as alpha equal to minus b plus under root b square minus 4ac upon 2a, and b beta equal to minus b and minus under root b square minus 4ac upon 2a. These are two square roots of the quadratic polynomial. After that, we are going to check if these are correct, or we are prove this one a plus alpha plus beta equal to minus b plus b square minus 4ac upon 2a plus minus b minus under root b square minus 4ac upon 2a, because we are going to add here, so LCM is denominator is same, so LCM is 2a minus b plus under root b square minus 4ac minus 4ac, because here is plus, so sign will never change, minus b minus under root b square minus 4ac. Now here value is same and opposite sign, so we will cancel it. Here will remain minus b and minus b, it will be minus 2b. In the denominator it is 2a, then 2 cancel, equal to minus b upon a. It means sum of square root, if are zeros we can say minus b upon a. Then product of zeros, then we will multiply the value of alpha and beta. So we have written here in the bracket both the values, minus b plus under root b square minus 4ac upon 2a into minus b minus b under root b square minus 4ac upon 2a. Here it is the value of a, it, it is the value of b, because it is a plus b, it is a minus b, So we can write here in the form a square minus b square. So square of minus b is b square, and square root cancel with the power this one 2 r square. So it, and because out of the bracket is minus sign, so we will change the sign also. Minus b square plus 4ac. B square cancelled because it is opposite and equal. So and we can write here remaining part is 4ac upon 4a square. 4a cancel, and a cancel. Here will remain only c by a. Therefore, product of square roots are 0 is equal to c upon a. It is verified here. Uh, Now we are going to explain, or then thank you for watching this video. Have a nice day. You have given so much time, so it is thanks for you.